Hello everyone, I'm Aaron from DataStax, and today I'm here to help take you through evaluating your Cassandra cluster for migration to Astra DB. And this is the third part where we're starting to look at some of the metrics that might be helpful from your observability platform in kind of ascertaining where your cluster's at and what you might need to look for while moving forward with the migration. All right, let's go. So after a short introduction, we're going to spend some time today talking about watching your operations per second to establish peak usage times on your cluster. We'll take a little look at CPU, although CPU isn't as terribly important, I would say. But kind of the main thing to look at is, statistics around like your disk footprint and throughput. So we're going to have a look at that as well. All right, as I mentioned in the other video, the paradigm we're looking at for migrating a legacy Cassandra application is going to be through the view of the old Killer Video demo app that we built up several years ago. Again, Killer Video is a YouTube clone that was kind of created as a reference application just to show what you could do with Cassandra and DataStax Enterprise. So here we're going to use Killer Video to show how we would kind of migrate some things along. So operations per second. Sometimes denoted as like ops per sec. Usually it's like the combination of reads and writes that happen on your cluster in any given time period. So like, you'll have some applications that'll be very, very read heavy, some that'll be very, very write heavy, some that will accept writes throughout the day, and some that will like kind of bunch up their writes in like an overnight job. A good example of, something for retail that might fit this would be pricing. You'd update pricing with a job overnight and then let, all of your stores and your website hit your pricing cluster throughout the day, which is mostly just going to be read traffic. And then you get the, like I said, you get the writes overnight. But that's a good way to, kind of suss out a little bit about how your cluster is used. It'll give you some idea of kind of the precautions and other steps you might need to take for a successful migration. The important thing though is that you do want to keep an eye out for like operational peaks. In a typical business day, you'll have like a high point that usually repeats, like a peak usage hour or time period when your business sees the most action throughout the day, or your website sees the most action throughout the day. Likewise, too, you might have multiple days per week when you do more business than others. You're going to want to make note of those as well. And of course, what about weeks per year? What about certain time periods in a year that if you're a retailer, perhaps you don't want to schedule a migration during November, December. Maybe February is probably a better time of year for those with like seasonal or holiday-driven peaks to do a migration. So that's important to keep an eye on as well. So CPU in terms of Cassandra-based databases, typically you'll see it go up during compaction, during operations like repair. If you have indexes that are being built or rebuilt, you might see high CPU during those times. High CPU, though, in a Cassandra cluster is typically not an indicator of a problem. Like I said, there are certain operations where you will see higher CPU. It's certainly not something that should happen during like normal operational traffic. So CPU, maybe not as important. I mean, to be honest, I've worked on Cassandra teams before where we've not alerted on high CPU just because, it tends to happen during some of those routine operations, and in the end, it doesn't constitute anything worth looking at from like a support standpoint. So CPU, yeah, it's important, but not as important as you might think. Okay, disk metrics. Kind of the main thing that you want to keep an eye on for your cluster, especially for migration, is your actual disk footprint. So, that'll be like, how much space on disk are your SS tables taking up? Are your tables defined to use compression? Because that's going to make a difference too. What about your snapshot directories? Make sure that you kind of have a feel for how big those are. Actually, though, I was speaking with one of the other engineers in our company, and she mentioned to me that if you go ahead and you run a node tool snapshot to take snapshots on your cluster, and you only have one snapshot out there, the snapshot directories are actually then a pretty good indication of what your disk footprint looks like, and is very useful to other DataStax engineers who are trying to help you with the migration process. It's also important to remember your replication factor. Most clusters I've worked on have had an RF of 3. I have worked on some that have had a higher replication factor than that, but usually going beyond 3 is not something that's required. You can also keep an eye out for disk throughput as well. Like an eye on like your read throughput and your write throughput. But that's something that you'll want to kind of watch during the migration process, as well as once you're migrated over to Astra or you're testing Astra, to make sure that those disk throughput metrics are still within like reasonable bounds for you. And it's important to note that when we're asking, as DataStax here, trying to help folks out, migrate into Astra, and we ask what their data footprint looks like, and they say, oh well, in this table, we have 10,000 rows, in this table over here we have 2 million rows. The number of rows really doesn't tell us a whole lot. It's more about like what's the actual data footprint on disk that we need to know. So don't focus so much on the number of rows. All right, so real quick, I thought I'd demo how to, have a look at your disk footprint and get an accurate picture of what that is on your cluster. So I'm on one node of my DSE cluster here. That's running for Killer Video. So what I'm going to do is go to CD. I'm going to go to var lib Cassandra. Let's have a look at that. Okay. Then I can go into data. I'm going to have a look at that. Okay, so you can see that I have all of my DSE key spaces, all the system key spaces, a couple for solar, but there are several there for Killer Video, and that's really what we're going to focus on for this one. So at this point, I have already run a node tool snapshot command a while ago, just so that it could go ahead and kick that off and get that operation going. Usually it runs pretty fast. It takes place in the background. But I should be able to see the results of that now. So if I use the Linux command of du to kind of have a look at the disk usage, I can say -h for human readable form, and I want to go with a depth of 3, and I only want our snapshot directory. So let me pipe that over to grep, and then I can just say snapshot like that. Let's see what that gets us. Okay. As you can see here, I have a list of all of the snapshot directories for my cluster. And you can see that I have the size available as well. Now, obviously, this is not a production cluster. Killer Video is a reference app, a demo app. So my disk footprint is actually pretty small. We're looking at like 20K, 20K, 16K, 140K. Yeah, we're really pushing the bounds here, right? But again, the idea is that you can get a better idea of what your overall data footprint looks like, going forward. And this is only on one of my nodes in this cluster. So anything that I see here, I need to remember there's 3 nodes in the cluster. So I need to multiply this by 3, for 3 nodes in the cluster with an RF of 3, and that will get me my actual data footprint. Also, too, if I wanted to just focus on the Killer Video key space itself, I could do a CD Killer Video. And we can have a look at that too. Yep, you can see all of the tables that are in the Killer Video key space. These are the directories that kind of hold the SS table files. I can kind of take the same approach here. I can do a du-h-d, and we'll just go with a depth of 2 here. And again, I'll pipe that to grep and say grep snapshot. And here you can see the disk footprint of the tables in my Killer Video. I can do a pwd, my Killer Video key space, and you can see what my actual disk footprint looks like just from my application. So this is one way that you can go ahead at the system level on a node and have a look and see, what your actual like disk footprint looks like. All right, Thanks for paying attention to this short video. I hope you gained some insight as to some of the metrics that you need to keep an eye on for a successful migration. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you, and have a great day.